Okay. Part of lesson 2 are some special types of equations that don't end with that you're used to. So most of the time they end with just one solution, like x equals 2. But sometimes there is no possible number that could work as a solution to the equation. So if we go to solve this one, like we always do, we have negative 8x minus 4 equals negative 8x minus 2. And right away you might notice that there's no way there could be a solution because this side does not equal that side. Because the negative 8s are the same, but negative 4 does not equal negative 2. So you could stop right there and say that there's no solution, and you draw that null set. Or if you want to add 8x to both sides, you have negative 4 equals negative 2. That is not true. So there's no solution. No, doesn't matter what number you try to put into x on both sides, it will never equal each other. Okay, and then there is sometimes where an equation has every single number could work as a solution. So if we solve this, we have negative 5 minus 9x equals 3 minus 9x minus 8. If we simplify this side, we have negative 9x, and then 3 minus 8 is negative 5. And over here we have negative 5 minus 9x. So we can see that they're exactly the same on each side. So we can stop there and put the little infinity symbol, because that means all numbers work, every single number. You could plug every number in both those x's and both sides are going to be exactly the same. Or you can go ahead and add 9x on each side, and then you have negative 5 equals negative 5. So either way, oh, excuse me. So there's some more examples for you to try, and some of them might turn out with regular answers, like one solution. Go ahead and pause and see what you get. Okay, so on the examples that you tried from 1 and 2, you should have gotten the infinity symbol for number 1, because if we minus 3x on each side, we end up with 6 equals 6. Number 2, they're just trying to trick you that, it's just a regular one with one solution. And then number 3 and 4. 4, let's talk about first. You should have gotten the null set because it ends up being negative 13 does not equal 42. Number 3 is a prime example of where people think it's a null set, but x can equal 0. So when you get down here and you have 58x equals 0, you divide each side by 58. 0 divided by 58 is 0. So you put a 0 in here and a 0 here, and the sides equal each other. So x can be 0. Please make sure to practice the homework for this.